Hello, everyone. Let me know. Oh, did the music stop? It shouldn't have. Oh, it did. Weird. There's maybe a loose cable. That's all I can guess. Hello, everyone. Here I am, erasing the whiteboard to get started. Let me know if my audio is okay. Unfortunately, I'm not looking at the chat right now. This is, I was going to say it's 3 days in a row, but it's only 2 days in a row. But it is, was I doing this on Friday or Thursday last week? Because if it was on Friday, that's kind of like 3 days in a row, because, you know, maybe I shouldn't count the weekends as work days for me. Let me just check the chat to make sure the sound is fine. All sounds good. Sable Raff is here. So there might be a loose cable with the music. I'm just going to put this on just to see. Oh, weird. Also, no music in this. Let's fix that. Yeah, I'm obviously doing the important work while people are coming in. Here it comes. There you go. Let's see if the music plays through. Not the most important detail for today. You might be asking, why are you erasing this? Aren't you going to need this diagram? And the answer to that is yes. I just plan on redrawing it. So you should know that the first part of the stream is going to be taken up by me carefully redrawing all of these tiles, because I have a new way to notate the edges, thanks especially to Telemaco. I don't know if Telemaco is in the chat. I'd like to believe that I would have arrived at the solution on my own, but I had some wonderful help overnight by way of GitHub issues from Telemaco, and also, oh, I'm forgetting the name, starts with a G, Galazaga? I'm gonna go look at the chat to see. Let me pull up, oh, something, oh, you know what's going on here. I know why the music cut out. So I guess I can't do this. My iPad where I look at the chat only had like 8% battery. So I plugged in my laptop charger into it because it's a much more powerful charger but I think it's causing all sorts of problems with my laptop not being plugged in and trying to do HDMI out and audio in, and it's powering all these other things. So we will just use the sad plain vanilla USB-C cable connected to a little outlet there, and plug this in. So it is getting some charge. All right, thank you, Evil Genius Lab. Welcome. Telemaco TV is in the chat. And then I'm looking for our intrepid viewer, which I will just go to the GitHub repo. Issues. Garazbalg, who also sent some wonderful suggestions and issues. And so I'm going to talk through all this in a second. Let me finish wiping down the whiteboard. So let's get a little business out of the way. So today's stream, I have a hard out. One is both of my last streams were closing in on 4 hours, which isn't healthy for anybody, especially me. I mean, you shouldn't be watching for that long. Although I am moving around a lot and using up a lot of energy, so it's not as if I'm hunched over at the computer for 4 hours straight. But I need to eat and do other things. So what I'm happy about today is I have a hard out at noon. Partially because of my schedule, because I have other things this afternoon that are scheduled for me, but mostly because at noon Eastern time, which is a little less than 2 hours from now, on Sable Raff, who's in the chat Twitch channel, is his weekly stream, and there'll be a guest, Ana Carreras. If I said that correctly, if I said it incorrectly, I apologize. And so I'm hoping that everybody who's watching here who might be interested in that can slide on over to that stream. We're all of us creative coding streamers are just we're going to coordinate our week so that you can continuously watch, although this would not be healthy either, continuously watch creative coding streams 24/7. No, nobody should do that. You should all get outside if you can. You should all be with your friends and family and loved ones and cook food and play music and do all the things that are part of life in addition to sitting hunched over your computer making algorithms make pretty pictures, which is also a kind of an awesome thing. All right, coming back over here. So what other business do I have to attend to? I have a list of things to go over eventually, but I'm just on a one-track train here, which is wave function collapse. Okay. All right, so the first thing that I want to do is redraw. I know this is going to be somewhat painful for those of you, but I was planning to start at 10:30, and I could have done all this just silently on my own, but I thought I'll just turn on the stream. So I'm going to draw all these tiles. I don't need this one anymore because we're not going to do that. So this is 13 tiles. I'm going to zoom this in here so I can see it. I'm not recording to disk yet, so somebody please remind me to do that when the time comes. And I'm going to carefully draw these out. So it'd be nice if there were 12 tiles, right? There's so much symmetry to 12, 13, although I love the number 13. Okay, 1, 2, 3, 4, 5, 6, 7. Yeah, let's do columns of 4 and 1 extra. Okay, so 1, 2, 3, 4. I'm drawing these way too big. Not necessary. 1, 2, 3, 4. 1, 2. I'll just make these smaller to fit 5 and 3, 4, 5. Okay. So, and how are they arranged there? Is it counting down? Yeah, 0, no, across. Okay. So let's do, this is tricky because I want to put things, you know what, I'm going to put the, no, I need to draw in the center. That's fine. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I really should be recording this to disk, but I don't think it's entirely necessary, but I might as well. There's no reason not to, so let's start recording this to disk. Hey, if you're new here, say hi in the chat. You know what my favorite thing to see is? Chat message from first-time viewer. I don't know why, but that just delights me to no end. So I'm not going to see it right now, but okay. So 0 is blank, 1 is blank. So but this is, all right, let's fill this in. All right, this will be filled in. I'm going to figure this out. I'm just going to do this slowly. Green. Then we got the circle in the middle with the green and then the gray stripe. Circle in the middle with the green and then the gray stripe. Let's just note this as gray. Then we have the crazy piece and the other crazy piece. And then this piece. Okay. Then we have the green stripe with the gray stripe. Oh, do I have colored markers? What is wrong with me? I do have colored markers. What is wrong with me? Oh, Simon, what is wrong? Why can't I think of such things? Okay. So I'm going to use this for the light green. Okay, there we go. This works because this is, I'm filling it in for black. Now 6 is the green stripe across. How's the focus on the whiteboard, by the way? Would very much like to know that. Okay, 6 is a green stripe across. 7 is green and gray. So we're going to say gray. Oops. And then these are, I do have more than just 2 colors, but so I could like use red or something for the gray, but it's fine. Okay, there we go. 0, 1, 2, 3, 4, 5, 6, 7. We're on 8. Is it Sudoku time again? Yeah. 8. 8 is a weird one, but it's okay. It's kind of just the equivalent. So we can do this. And this is gray. And this is green. Okay. Then we've got 9 is, my favorite tile of all, because it's where everything began. It's where it all began. We have 9, which is all green. Ten is 2 stripies, 11 is 1 stripe. Okay. So we've got stripe, 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 and 11 is 1 stripe. And 11 is 1 stripe. Oh, this green is mixing with the black. It's very unpleasant. And then 12 is a big circle with 2 greens. Okay. Now, I want to figure out if I need to notate the background of any of these. I believe the background of everything except for this one is a sort of dark gray. Let me just look to confirm that. I've got to come over here. Not dark gray, dark green. Dark green, dark green, dark green, dark green, dark green, dark green, dark green. Yep, 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 yep. So the white background is the dark green. If it's gray, I've noted it with the word gray. Which is this here is the question. I didn't mark that. Under number 5, that 4, that is a green. Okay. So this is green here. So we only have 3 colors, really. Well, no, we have 4. So I need a key. I'm gonna do that as part of the video, except for the fact that I don't have any space left. So maybe I do want to color in the gray. Let's color in the gray. Let's use blue for the gray. I think that'll be better than writing the word gray. That'll be helpful. Let's use blue. So this is blue. This is blue. this is blue. I mean, it doesn't matter. The center stuff doesn't matter, but both of these are blue. It doesn't really matter, but it helps. So white is actually a color, which it maps to the green. Black is a color. So the only colors are black, what in my notation here, black, white, green, and blue. Okay. All right, let me come over here. So I will kind of briefly explain and recap where 4 also has a green cable. Okay, that's an older comment because I did get that. I've never seen color. Just in case you're all wondering what's going on here, I will show you. I have purple. I have a whole box of markers here. I just never used them. I mean, this is a recent purchase, so. My New Year's resolution, because you can make New Year's resolutions in what's practically May, more colored markers. Okay, let's clean up some of this garbage. Hello to this camera. And it's just about time to get started. Okay, so if you haven't been following my recent streams, I don't know why this computer keeps going to sleep. Is it plugged in now? It is plugged in now. I4 has some gray too. I mean, I guess if I'm going to try to be consistent, it is a good point you're making. These are gray. Yeah. It's not relevant given that the only thing that matters are the connections, but I should be consistent. Yeah. Okay. All right. So what I have been working on is, let me just see here, a P5.js version, and I think I can move over to here now, a P5.js version, and by the way, did everyone see my new mug? Oh, delicious. A P5.js version of this algorithm called wave function collapse. This is now the 3rd stream that I have dedicated to this. I've spent about 8 hours on stream working through this problem. You know, a lot of that time was me just babbling on about other topics or trying to solve a Sudoku puzzle. But definitely a lot of time has been put into working through this. Interestingly enough, I would say even after I finish the part that I'm going to do today, I don't even know that I'm halfway done, because there are 2 distinct flavors of this particular algorithm. There's the tiled model and the overlapping model. I'm planning, maybe tomorrow I'll be here starting the overlapping model. Who knows? But I'm working through the tiled model right now. One thing I really want to know is what is the visual? I mean, this is not relevant to right now, but I'm fascinated by this visualization of showing, I guess it's like visualizing the possible tiles that could go and then like alpha blending them. It's fascinating. Anyway, this is all about the overlapping model. And down here, what we're looking at is an explanation of the tiled model. And what I started with, if I hit refresh here, is, and this is thank you to Loic, I think that's what Loic said, who submitted these tiles. But this is a way of creating a, what you might call like a procedural terrain, a 2D space out of a selection of images that represent tiles. And if I go to, if I go to the Finder here, under Desktop, under Wave Function Collapse, and look at mountains, you can see these are the 4 tiles. The simple ones that I started with that will actually show up in the video are these, which are essentially the same, just not as visually interesting. And then you can imagine, every time you run this, it's the same every time, because I forgot. I really should take the random seed out of the code base, but that will come later. It's going to pick one of these randomly to start, and then once you've picked one, only other tiles that connect to that can go around it, and so on and so forth. There's a lot more to it than that. There's all sorts of pieces of the algorithm that are quite sophisticated that I haven't implemented and optimized, but I've got the basic idea going. And yesterday, I wanted to investigate looking at a more sophisticated scenario, which was this particular PCB board-like design, which comes with 14 tiles, each of which can be rotated on any particular angle. And if I go to the circuit branch, and I'm sorry, I have to remember to bring this up a little bit so you can see the bottom. Check out circuit. Yeah, fine. Now, and if I come back over here, now you will see this appears to be working, but it's not entirely because of a symmetry problem. So the thing that is really different about these tiles, let's see if I can go to view as icons, and I can zoom in here for a second. I keep saying 14, 13 tiles. I don't know why I can't get the number right. Yes, I am recording to disk. Thank you for the reminder. It is going, so I'm good that way. All right, so the thing that is quite different about these tiles is not all sides are symmetrical. And you can see, I'm going to delete this one here. So in other words, sorry, you can see like tile 0. I could rotate that at any particular angle, 90 degrees, well, not any angle, any multiple of 90 degrees, it would be the same tile. It's like fully symmetrical, horizontally, vertically, etc. 2, I could flip it horizontally or vertically, and it's vertically symmetrical. Each side, oh, what we're looking at is the sides. I should look at the whiteboard. With that, I can gesture to these things more easily. So if these are all the tiles, you can see sides are either symmetrical or they're not symmetrical. And I kind of talked this through in the video, so I guess I could use this part, but I mean, I'm kind of ready to just go into it, so maybe I should do that now. So the quick TLDR I was doing like a little bit of catch up. It also helps me kind of remember where I was. Let me just keep going, and I'll come back and do this again. So sides are either symmetrical. Like, look, that's symmetrical. That's symmetrical. All these sides are symmetrical. Even this, like, we're not looking at is the tile symmetrical. The important thing is the side symmetrical? Like, what's along the edge? If I flip the edge, it's symmetrical. And the only tiles that are not, that have sides that aren't symmetrical are this side, and this side, this side, and this side. So I need a more sophisticated way of encoding the sides so that sides match up with their reverse, right? If a side has kind of, like this side has black, white, white, I need to put up top one that is black, white, white. No. Oh, but when I'm rotating, I have to rotate them when I rotate it. Oh, that's interesting. Right? Because this is going to be black, white, white. But when it gets to the bottom, it's going to be, if I'm reading left to right, white, white, black. And it wouldn't match up. Like, I can't take this side and match it with itself. It needs to match with its inverse. If I think about this as 1, 0, 0, it needs another tile that is 1, 0, 0. Oh, but I could just say, I'm so confused. I've already confused myself. I'm going to have to work. The point is I should be working through this in the video. That's the point of everything. Yes, it can't connect to itself, right? can't connect to itself. 1, 0, 0 has to connect to 0, 0, 1. But, oh, I need to always write them out. Like, but this is what I'm confused about. This one will be 1, 0, 0. Won't this one be 1, 0, 0? And these do connect. And that's it connecting. So this is really 1, 0, 0. That's what I have to write it in reverse, even though I don't see it that way. That's what I'm confused about now. Help me understand. Read clockwise. Yeah. So I do have to read them clockwise. It's just like, that makes me crazy because I have to look at, I guess that I have to look at it. Oh, because if I flipped it, if I rotated it, it would be 0, 0, 1. Yeah. Okay. That makes sense. Okay. It took me a minute for my brain to, all right. So this is why I should have, that would have made sense for me to, but I'm going to rehash this. Okay. So, just so everybody knows, I'm going to make, as I get here, I'm going to credit, but let's go to, so this is Garas Bog's example, which is super helpful and uses a way of encoding, which I think is what is described on the GitHub page, calling them like SL and F based on like what side it's on. And then as you're rotating it, it changes. But I think I like this other solution, which is Oscar. I want to come to here. I'm going to show this. And can close that. I like this solution here. Yeah. Reverse string, yep. I guess I could look at the pull request, although I kind of want to do the, colorable. Somebody added a new, I like this. Cool. I like that. So I don't want to look at the code, but I want to look at the explanation. Yeah, so we can see like this here. That's what I'm basically going to do. I guess I am looking at the code. So let me go look at the explanation and the issues. Yeah, which is being described here. So even though I could do something where if it is symmetrical, I don't bother to encode it as 3, but I think I'm just going to encode every side as having three colors. And then that is also exactly, let's load this page up. Move these things out of the way. That's exactly what's going on here in this particular example. If we zoom in, we can see the hex codes of the colors here. Okay. The fifth tile can't connect to itself even if rotated. That is correct. The fifth tile can only connect to the various corners of the fourth tile. So that is correct. I only need S and F because all of the left and right sides of every tile are symmetrical. But I think it's time for me to now turn this into something generic that you could design your own tiles, in a variety of different ways. Okay, so here we go, everybody. So unfortunately, I don't have a clear picture in my head of where I last left off. So I'm going to kind of guess. And this is not an entirely new process because this is how most of my YouTube videos are these days. They're edited versions of the long live sessions, but this one is a bit unique in that it is now going on a third session. I did this a little bit with the auto encoder, but as you might the two projects that are lost to the live streams are the auto encoder, which I would love to get back, and the self-driving car, which I think I would like to do again, because I got to do some more work on the ML5 library though before I can get to that. All right, so here we are. I have a blue marker, I have a green marker, I have a black marker, which is a good one. And I'm going to get going here. All right. Okay. I'm trying to think about what I'm going to say. This is where having a script would be helpful. Oh, we're going to get there. Okay. So just out of curiosity, I want to look. So I think, yeah, so it's marked here left to right, just so you can visually see it. But I guess somewhere in the code, it knows to flip it. Right, the numbers need to go clockwise. So how does it, I'm just thinking of it, is there a better way for me to represent it if I were to draw it on the board? Like I kind of want to draw it on the board matching the sides, like how it's visualized here. But really this one should be written in the data, it would have this first. You're writing them left to right if this particular side was rotated onto the top. Them in the code read clockwise right. Because each tile I would just like in other words, let me think this through a little bit. When I do this, make it a string. Why don't I just make it a string? And that will, I will read that string in clockwise, but I will mark it correctly. That's what I'm going to do. Although it would be simpler if I divided it into 3. Then I don't have to, then my code's going to work the way it would before. Yeah. Yeah, rotate it to have that side on the top and read it. So I think I'm going to mark it on the board. I think I'm going to mark it on the board where the values line up correctly. Like, I have to make a key. Like if 0 is black, 1 is white. Like I'm going to mark this 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0. Like that's what I'm going to write here. But as I enter it into the code, I'm going to enter it in the clockwise order. Beautiful. Wonderful. How's everybody feel about this plan I have now? Everybody feel good about this plan? We're going to be done in like 15 minutes. Hour to spare. Okay, finally work on macro data refinement again. Okay. Did I just say 15 hours? Not 15 minutes? I don't know. All right. All right. I'm back here. Brown, blue, blue, wrong. Yes, clockwise. Bye, Sable Raf. We'll see you in an hour or so. All right. Hold on one second here. Well, that's just me blowing my nose. Everything's fine. I don't have the noise reduction on. Okay. Welcome to day 3. This time, I'm finally going to complete the wave function collapse algorithm. Maybe we'll use that, maybe not. So first, I have to say a big thank you to, okay, how do I say, Telemaco, and I'm going to leave this open. Garazbalg. I'm going to just, this is all going to get recaptured later. We'll show the GitHub issues, etc. First, I need to say a huge thank you to Telemaco and Garazbalg, who overnight, while I was sleeping, added some GitHub issues on the wave function collapse repository, pointing to the keys to unlocking the asymmetrical tiles and placing them correctly that I was struggling with yesterday. The best place to another incredible demonstration. I don't know if does anybody remember if I referred to this project at the beginning of the video? I don't think so, actually, to be honest. So I think this is coming up now. Just making sure I'm recording the disk. Audio looks good. Okay. An incredible demonstration of the solution I'm about to attempt is from Oscar Stahlberg. I don't know what to call this. Okay. An incredible demonstration of the solution I'm about to attempt is from Oscar Stahlberg's wave function collapse demo. And I'm saying demonstration twice. An incredible demonstration of the solution I'm about to attempt is Oscar Stahlberg's Unity implementation of wave function collapse. In it, you can interactively start to select tiles, and it will visually show to you which tiles are left. You can also let it run and watch the process as it selects the tiles, and the magic of wave function collapse unfolds over the screen. So I'm going to be, when the video comes out, we'll be putting that and rendering it behind me. The beautifully designed tiles of this demonstration are not symmetrical along the edges. But they all, much like the tiles I'm using, only have 3 components. Well, that's, no, they have, yeah. But each edge can be divided into 3 parts. The left part, the right part, and the middle part. And as long as brown matches with brown, blue matches with blue, half brown, half light brown matches with half light brown, half dark brown, the process will work. But JL says it's so cool to see your process of coming up with the wording. I used to not do this. I used to just talk. But now that things are being edited, I'm kind of giving myself a little bit more leeway here. All right, let's go to here. So thanks to the magic of my colorful markers, I have redrawn all of these tiles for you. And let's look at how I can, okay, let me do this again. And thanks to the magic of these colorful markers, I have redrawn all of these tiles just for you. And I think I can make a key to describe all of the tiles, the edges of the tiles, divided into 3 parts. So I think I can make a key to describe the So I think I can make a key to enumerate all of the possible parts with each edge divided into 3 that could be on any tile, symmetrical or not. So this first tile, which is a black tile, has black, 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 black. So this first tile, which is black, has black along all of the... So this first tile, which is all black, is fully symmetrical along all the edges and all rotations. I'm kind of off the screen here. So I'm going to say black. I could use, maybe I should use letters. And I think because I've numbered all the tiles, it might be easier for me to use letters here so that we can really distinguish what's being matched with what. So I'm going to call the black color A. White, which really in the actual, white, which really is a dark green in the actual color, white, which really is a dark green in the actual tiles, I will call B. I hate that this is here because now I'm constantly going to, I guess I could move this over a little bit. There we go. So now this side will be A, 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 A. One color all around all the parts of the edges. Same for this, but with B. Finally now, with tile, the image number 2, we will get something a little bit more interesting. We've got B's all around these sides. Those are some very funny bees. Did anybody get that reference? And then I've got a bee here and a bee here. But now I need a third color for light green. We'll call that C. The blue color here is actually gray in the blue color here is actually gray in the, I'm standing in like a weird spot. Let me just stand here. The blue color here is actually gray in the tiles themselves. The blue color here represents, the blue color here is actually gray in the image files. A new color. We'll give that the letter D. So now I have B, 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 D, B, and so on and so forth. All right, I'm going to just pause and check the chat to see if I've gotten anything horribly wrong before I fill out the rest. A socket. Okay, that's a good idea. A socket. I like that. All right, yeah, okay, everybody seems to think this is looking good. Sorry, I'm over here. I know you're seeing the whiteboard. Now we've got the really interesting tiles, the ones with some asymmetry, which are easy to notate. Now we've got something pretty interesting, now we've got something pretty interesting, the asymmetrical tiles. But this system makes them really easy to notate. And I can go on and complete the rest. Oops, that's wrong. How did I do? I think I've got this right. Okay. So I'm going to go to this shot. I'm going to stop my recording just so I've got all that. Start recording again. Come back over to the code. Bottom C should be a D. Where's that? Ah, yes, thank you. One mistake. Thank you, live chat. Okay. First time chat from viewer. Daybreak Eats. That's my favorite thing, is a first time chat from a viewer. And I have my special coding train laser etched train whistle, which I know a lot of you are waiting for yours. Not a lot of you, because there's not very many of you who signed up to get one of these, but they're coming. We're working on them. If you have any questions about that, write to katie@thecodingtrain.com. All right. Let me see. Where's the chat? All right. All right. Hi, Kangaroo. I'm just going to go here. So now back to the code. First thing, now that I'm actually using all of the tiles and not making extra tiles to try to flip them, I can turn this into a loop, which is going to make all of our lives so much better. Don't you just feel so much happier now? I do. Don't you just feel so much more at ease and comfortable? Don't you just feel so much more at peace with the world right now? Yeah, that's I got the 13. Yes. Don't you just feel so much more at ease and relaxed? I know I do. Here, I'm still going to, now when creating the tile objects, I still need to do that individually because I'm going to manually assign all of the when creating the tile objects, on the other hand, I still need to do that manually, one by one, because I have to custom notate all of the letters for the edges of each tile. Missing array index. What? What did I do? I know, we don't feel relaxed. Tile images. Ah! No, I'm not relaxed at all. In fact, I'm totally panicking. That would have been very unfortunate to find later. But now, okay. Nonetheless, these tiles still have to be, these tile objects still have to be created one by one. Nonetheless, these tile objects still have to be created individually because I'm going to manually notate all of the letters for the edges. And by the way, okay, I know. Let me, just so you can see. And by the way, there's a key term that I should be using when talking about all of these edges, and that is the term socket. You can think of each section of an edge as a socket. Each socket must connect to another socket of the same type for them to match up. And by the way, I encourage you to try having more than 3 sockets or fewer than 3 sockets. So many possible things you could do if we could get this working. The one thing that's going to be really confusing is, what is the order by which I write the letters for the sockets? This side socket is BBB. Well, this side socket is also BBB, and I don't have to worry about what order because they're symmetrical. But this one I really have to think about. This side socket is ABB. And it needs to connect, sorry. Move this over a little bit so I can be in the shot. This side socket is ABB. Okay, I know what I'm saying now. Oh, I need more whiteboard space, but I think I can just demonstrate it here. This side socket is ABB. Does it connect to itself? Well, you might think it does, right? Because what it wants to connect to is something that looks like this. A matches up with A, B matches up with B, B matches up with B. But if I took this side and put it here, I would have to do that by rotating this all the way around. And suddenly, this socket, this side rotated around, would look like this. These don't match. But this side, if I were to take this side and bring it up here, it would match. But this says ABB. These are not the same. While this one says ABB and this one says ABB, those aren't the same orientation. I need to make sure I'm notating everything in the same order, which means in the clockwise order. It's the way I've been thinking about this project all along. Up, right, down, left. Up, right, down, left. Up, right, down, left. Up, right, down, left. Sing it with me, everybody. So even though I guess I'm standing over here. So even though I most definitely want to draw it this way, because it'd be way too confusing for me to write BBA and not see that match up, when I put it in the code, I need to say the note. When I put it in the code, I need to notate it as, when I put it in the code, I need to notate the sockets as ABB, BCB, BBA, AAA. Then edges need to match up with other edges that are asymmetrical, inverted. Then edges need to match up with other edges that are inverted so that they lock together. Right, and I should note that probably a more traditional way, and I also should note that another way to approach this order would be north, east, south, west, which I could have been doing all along, but somehow my brain is going up, right, down, left. So coming back to the code, it's a matter of me looking right at that whiteboard and adding all of the edges in. I'm going to YMCA. Just looking at the chat. Then we were confused east with west the whole time, I know. So now as I prepare to enter the edges into the code, looking right at the whiteboard, for tile 0, this is easy. It's just going to be AAA in all 4 spots. Tile 1, all Bs. Now with tile index 2, I've got the top as BBB. But I need to make sure I read, just go to, but I need to make sure I read BCB in this order and BBB in this order. Oh, but these sides are symmetrical. So again, it's only going to matter when I get to 4 and 5. Oh, sorry. Don't worry, I was recording that, though. Sorry that I'm in the wrong screen. Camera, thank you for telling me. Yeah, let me. The exceptionist is making a very good point, and I will address that. I'm going to get to the end, and then I will address that. And here I am at index 4. ABB, that's the top. BBB, that's the right. And now this one, I'm just not going to switch to the whiteboard. You all know what I'm doing. And now this one, even though it's written here the way I would read it in English from left to right, it's not really English. And then this one here, even though the way that I am sort of wired to read things from left to right, of course, that's not how everybody in the world is. I want to make sure I read it. Is that weird to say? And here, I don't know, lost my train of thought completely. Now for this one here, even though I'm wired to read it from left to right, I need to make sure I enter it from right to left, the way that it would look if I had flipped it, rotated it, so that this side were on the top. BBA. And then the last edge is AAA, from bottom to top. I think you get the idea. Now, one thing you might be asking yourself is there a way to automate this? And in fact, Now, one thing you might be asking yourself, is there a way to automate this? Actually, do you really need to enter it in all manually? I think in this case, there's probably, let me just put it on here for right now. So you might be asking yourself, isn't there a way to automate this? I mean, do you really have to enter it in manually, one line of code at a time? And the truth of the matter is, with these tiles, there's probably a way that we could start to look at the pixel values, the color values of the tiles, those pixels along the edges. There's probably a way we could look at the color values of the pixels along the edges, and there's probably a way we could look at the pixel values along the there's probably a way we could look at the color values of the pixels along the edges and generate the sockets based on those color values. But that's a project for another time. I'm going to stick with doing it manually here. Tile index 5. Let's do the rest of them. Six is, so please tell me in the chat if I get something wrong. Maybe I should do this so that everybody can see. Whoops. What tile am I on now? 8? Okay. Alka, are you not a mod? Can I make you a mod? Oh. I think you're a mod now. Tile 11, BCB, BCB. Whoops. Oh, this is making me crazy. Gotta move this over. Wait, what is going on here? What is going on? Okay. How come I can't like make my Visual Studio Code window go over a little bit more space? Okay, fine. I will deal with you later, Visual Studio Code window. Okay, now why? I guess, do I just have to make this wider? Fine, fine. I will. Let me see where I'm standing here. That's fine. Move myself over a tiny bit. I must do this. Otherwise, I will not be able to live with myself. No! All right, fine, fine! No, I know I can do this, but I don't want to do that. I guess I could because I really only need this tile. Okay. Tile 4. Okay, did I get that wrong? Tile 4. ABB, BCB. Oh, that whole time I did it wrong. No, I did it right. BBA, AAA. Tile 4 is wrong. Do you mean like the 4th tile or tile 4? A, B, 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 oh, B, C, B. Oops. Oh, whoops. Sorry, one error here on one error here with tile index 4. That's BCB. So now that everything's in here, what else needs to change? Certainly the way I'm checking if two edges are compatible, if the sockets fit together, that needs to change. Where is that? Should I just run it and wait for the error? Let's run it and see where the error is. Let's run it and see where the error is. Line 146. Ah. Tiles option. Yeah, that's what I'm wondering. Option is now the string. Yeah. Oh boy. Okay. Let's look at what the tile object looks like again. Whoops. Oh, oh, actually, what? Oh, amusingly, it just got stuck at the beginning? That wasn't actually the error? Wait. That's sort of hilarious. Yeah, everything is still right. Shockingly, it still works, but it's not giving me visually the result I want because I'm still only checking if edges are equal. And actually what I need to check is if an edge matches its, if an edge as defined by the string equals the reverse of that string. Yeah. I do kind of love the weird pattern that I'm getting here, but let's correct it. Check valid. It looks at what options do I have and what are valid, and if they're invalid. Okay. Let's see here. Let me start this over. Let's just run the code and, oh, sorry, hold on. Well, Matt, too, you can't use this background. Sorry. Hold on. Let's just run the code and see what happens. Amazingly, it's still working. Now, I suspect, even though the code is, oh, I got to take that console log out. Let's just run the code and see what happens. There's bound to be an error somewhere. Amazingly, I'm not getting an error, but I'm also getting a pattern that isn't exactly what I'm looking for. Well, now I got an error because it came up against a tile where it couldn't figure out what goes there. And here now we're seeing a strange pattern that I don't even recognize, but I do kind of love. The key, of course, is to not check. So what I'm doing currently in the code is checking if one side is equal to another side. So can BBB go with BBB? Yes, those sockets connect. Can AAB go with AAB? Well, no, it shouldn't be able to. Oh, yeah. But back to here, can ABB go with ABB? No, those don't connect. But ABB could go with BBA. Remember, this side is really BBA. So all I need to do is, instead of checking equality, I need to check if one edge is equal to the reverse of another edge. And I believe that happens in the check valid function. Oh. If valid includes element. All right, where do I need to change this? I'm not checking if valid includes element. I'm checking if valid includes the inverse of element, the reverse of it. Is that what I need to do? The comparison is done in the tile class. Oh, yeah. Analyze. No, this isn't it. It's all about how I generate the adjacency rules. This is just analyzing. Check val is just checking to see based on the adjacency rules. So I need to regenerate the adjacency rules, which is in this analyze function. And here I'm checking if tile.edges, here's where I'm checking if one edge is equal to another edge. So let's write a function. Compare edge. Return A is equal to B. Is there a string function called reverse? There's an array function called reverse. So I think I need to write my own string function to reverse a string. That's not too hard. I could make it into an array. I think split takes a string and puts it into an array. Then I can reverse the array and then join it back together. I think that'll work. And then now I can just say compare tile edges 2 with this dot edges 0. And that's called compare edge. Now I want to compare 3 and 1. Zero and 2. And 1 and 3. All right. Are we ready? Is this going to work? We're about to find out. List.reverse is not a function. I could have sworn there's an array. Oh, I've got to give it an empty character from which to split. So just like I need to join them with an empty character to put it back into a string, I need to split it with that empty character. Okay. It's not a function? All right, hold on a second, everybody. Oh no. There's a function in P5 called reverse. Oh, P5, I love you so, but you always have these global functions which confuse me. That's not what I meant to go. So the reverse function in P5 actually does the work of reversing the array. But Am I not in a current version of P5? No, I'm there. But it does say deprecated. It will be removed in a future version of P5 because there already is an array.reverse function. So that all makes sense and everything is right with the world again. I just need to call this reverse string, which is more clear anyway. All right. You've waited long enough. All right. You've waited long enough. Let's see. No. Shoot. Assignment to a constant variable. Ah, I made it constant. Let. Oh, look at that. Oh, it's so beautiful. No, but that's fine. That's just the thing where it gets stuck. And guess what? If it gets stuck, let's have it start over. Let's fix that. Is it, if there are no valid options, what's a elegant way of handling this? Sorry, I'm just trying to think here. Like, is this loop executing? Even if this is empty? Hold on. I'm going to put my random seed back in just to sort of track the error. Well, that one didn't have an error, but it is lovely. Telemaco is helping me cheat here. I'm supposed to figure these things out. All right, let's try random seed 2. All right, cell options equals pick. All right, fine. Ah, if there's nothing here. Okay. Let me get to that, arrive at that myself. I mean, I guess I could. Ah, I see. If there's nothing, there's no options. Right. Okay, hold on. Okay. I can't seem to find the random seed that will give me an error. Aha, there we go. We got an error. So the error happens on line 136. And that is looking for it's so interesting though. I believe I agree that that's like the fix, but well, anyway. Well, I'm going to keep working through this. Okay. What was the line number? So tiles option is undefined. Let's see what's in up.options. This really slows it down to console log every thing that it's looking at, but we'll see. Okay, so the whole array is undefined, meaning there are no options. Aha! So if you're looking at a cell that can't have anything, I see. We're looking at a cell, okay. Aha! So we're looking at a cell that has no possible tiles that could fit there. We just happen to be looking at it from a different cell, but I believe we can head off this error by here, right? If a cell has no options, why is it? It contains undefined because pick is undefined. I think ultimately this is the only place. Okay, yeah. There's a weird clue here. The array isn't empty, like there's no options left. It's empty. It has an element. There's a weird clue here. The array isn't empty, like there's no options left. It's got one element, but that element is undefined. And there's only one place that I put manually one element into the array. It's this sort of weird way that over here, I pick from its options. And if there's no options left, what I pick will be undefined, and then place it in the array. So I think I have to say, if not any pick, if there's nothing that I can pick here, what do I do? Start over. Well, let's just say no loop and return. See what that gets us. But didn't it get further before? It just hadn't, it hadn't tried yet. Yeah. So it stopped earlier because it found a cell that has no possibilities left for it. It didn't discover that until it went later and picked a cell next to it. So there's I think probably some optimization and cleanup I could do in the code. But for right now, let's just have it start over. So I think there's some optimization and cleanup I could do in the code, and ultimately implementing backtracking, going back and trying a different solution would make sense here. But I'm just going to keep things simple and have it start over. There's enough times I can start over a few times and eventually get there. So I'm going to write a function called start over. In setup, I create all the tile objects, I put them into a big tiles array, I analyze all the adjacency rules, and then create a new grid. I think I could just start over by creating a new grid. So we'll call start over also in setup. Then create the new grid and start over. So if we ever get down to a cell with no options, we'll start over. There we go. So let's see how many times I have to run this before it fills. All right, there's something else wrong. Hold on, I'm looking at the chat. Just validate pick before inserting it. I agree with Alka. Yes. Oh, it picked 0. Yeah, not 0 is true. I can't do that. Wait, the if blank is wrong. Okay. You made if 0. Where's that? What line of code did I do that? Oh, look, I got one. Only 9 times. If pick, okay. I got one. But the chat is rightfully pointing out something that I didn't consider, which is that if not pick is causing a lot of false positives, because one of the options it could legitimately pick is 0. So I have to just actually say if pick is not equal to undefined, just make sure it's not undefined, then you can keep going. Or if it is undefined, sorry. If it is undefined, you can keep going. No, if it is undefined, start over. If it's not undefined, keep going. I think we finally have it, people. Let's run it one more time. Yeah, now it's getting further along before it will reach that error. There, now it got the error, and now it's going. There we go. I think this is our second attempt. Yay, and we did it on the second attempt. Amazing. Now, let's do something really exciting. Our canvas, let's get rid of random seed so that it'll do it differently each time we run. The canvas is 800 by 800. Let's try upping the resolution to 40 by 40. My guess is it's going to run very slow because I haven't optimized it, but I think my guess is it's going to run very slow because I haven't bothered to think about other ways to optimize the performance, but let's see what happens. What time is it, people? Oh, still good. It's going to be really sad when it gets stuck and clears the board. Question is, will it start to get faster as it moves on? Like, what's the bottleneck here? I think it is getting faster as it moves on. Is it the drawing of all these tiles? Or is it actually the algorithm? Because if it's the drawing, then it's not going to get faster. But there's much less work for it to figure out what to do. This is so satisfying to watch. I can't even begin to tell you. Oh, I think it's going to make it. Wave function collapse. We have it, everybody. There is so much more to do here. First of all, I haven't even attempted the overlapping model. I'm going to wait until you're sometime in the future actually watching this. This is a video on YouTube, so I can get a lot of comments and feedback, because I'm sure there's lots of things that I've done in sort of strange and odd ways that I might want to think about and address before I move on to the next version of the algorithm, which detects the tiles and adjacencies in a way based on doing a pixel analysis. That's a little hand wavy, but that's the general idea. I also haven't bothered, I also have left out a key element of the algorithm. Hold on, I just want to get to that part here. Which is explained really nicely in this processing forum post from Solib. The process doesn't stop to the 4 direct neighbors of the collapsed cell and has to be extended recursively to the neighbors of the neighbors and so on until all constraints are propagated. I'm kind of getting it to work anyway because I'm just doing a full pass through everything every time through draw. But ultimately, I could reduce the entropy by recursively propagating the cells as their options start to collapse. Did you get that? So give me your tips and thoughts about how to do that in the comments. Of course, there's backtracking. Would love to add that. And then, but really, this is what I'm here for. This is why I made this video. What possible tiles could you design, and what patterns and terrains and beauty could you create by just using my code exactly as is, not changing anything, but just designing your own tiles, creating your own key of sockets, and just running it and letting the beauty follow. I want to see this so badly. So comment on the video, go to the Code and Train website where there is a place that you can submit your version of this. Tag me on social media. I want to see the world full of beautiful wave function collapse algorithmically generated images. And stay tuned for the next coding challenge or sometime in the future when I tackle the overlapping model. Okay. All right. So I don't need that with this tile set. Got it. I guess I could address that. I only have 15 minutes before we raid. So I wonder if I could quickly, like, how easy is it to get one of these other tiles going? I just want to run this more. So all right, let me go back and kind of re-record that thing. I'm just going to like add an extra sentence here. See if Matsuya can fit this in. Now, in truth, the tile set that I'm using doesn't actually need this. Right. Right, that's such a good point. Now, in truth, this tile set that I'm using doesn't really need this because neighboring a tile, when it's collapsed, only affects its immediate neighbors, and that doesn't really ripple out in the same way that it might in, say, Sudoku. But this is definitely something that I would want to add to the algorithm in a future version of this. And if you have ideas and thoughts about how to do that, please leave them in the comments or file an issue on the associated GitHub repository for the code here. Oh, 3D. Oh, that's also like a really good point. I'm probably going to just have to like re-record an ending to this, but I'll mention that. I was over there. So maybe we can, I just want to run this again. Oh, it's running again already. Not to mention, this algorithm can be applied in 3D, and boy, are there a lot of incredible examples of this on the internet and other YouTube videos you could watch. Not to mention, this algorithm can be applied in 3D, and whoa, there are a lot of amazing visual... Not to mention, this algorithm can be applied in 3D, and whoa, there are so many amazing implementations of wave function collapse in 3D. YouTube videos, websites, I'll try to link a whole bunch of them, put them up on the screen. Oh, there's just too many to mention. All right. Oh, you didn't even see me saying that. You just heard me saying that. That's fine. All right. Mouse on the screen. Okay, yeah. Oh, I know what I'm doing. So first of all, let me commit this code. And you know what? Because it runs so slow, let me take it down to 25. Let me do 25. That'll be a nice happy medium. We're going to get a little bit more. Yeah, 25 will give us a little bit more kind of resolution here, but it still runs super fast. So I'm going to commit it with 25. Okay, so now do 2 by 2. I don't know what that means. All right, so now we are going to go to, did I not open a pull request here? So, all right, so where is, all right, let me go to circuit. Why? Where's my pull request option? Oh, I have it already. Why did I not see that? It's right there in front of my face, right there. Okay. Let's just see. This is the final version of the code. Still need, I do plan to comment and annotate it as much as possible. Comment, merge. Oh, okay. And then, so now you should be able to, and people filed some, oh, wonderful. Circuit with code. Oh, circuit with coding train colors. Ah, I love this. Mr. American Mike, I thought American 2050 in the chat. If you want to open a pull request just with a folder of these images, I would love that. I don't know if you could pass them to me quickly in the next 10 minutes. I can run it with that. Although I guess I can, you know what? Let me just do this myself. I don't need to trouble you. I've got them here. So I'm just going to unless maybe you want the pull request though. So I could manually, why don't you pull request it, but just that folder of images. So I don't have time to do this right now, and I'm glad that I don't because I would just keep going. But this one I really love. I love all of these. Like now all of these should be possible. So I don't know. So I think what would make sense actually, honestly, is to make a version of this that just loads the tiles from like a JSON file. Like there's a JSON file that has all the images and the socket values. And so like the code is just generic, and then people could have different JSON files and different folders. so that it could run it with different examples. But I don't know, I didn't do that. So, and I see a message said done, so maybe there's a pull request already that I can do. Opened 1 minute ago with just these, amazing. So let's throw caution to the wind here. Come on back to me, conversation, merge pull request. And now circuit coding train is what I'm looking for. And let's see what happens. Oh, look at that. That is beautiful. Oh, I love it so much. I love it so much. Now, I'm wondering, did I actually code this in a way that it would work if I did 800 by 600? No, I did not. So that's another thing I need to fix. It's got to be a square. That's not too hard, but I guess like, oh, because I don't consider the columns and rows. That's weird. Oh yeah, because so this would be easy for me to do, but I'm not going to worry about that right now. That'll get fixed another time, but it just have to be a square. Let's do this. I know it's so slow. I'm trying to think if there's, like, is it going to be faster if I don't bother drawing these rectangles? Like, is the drawing slowing it down? How much is that slowing it down? Not so much. If you do base 64 in the JSON, you can make a tool to generate the JSON file to make it manageable. Yeah. Yeah. The best version would read from a map of tiles and analyze the tiles. So this is all great beyond, that's I think more for like you all to implement, and we'll link to once we get it up on the Coding Train website and everything. It'll be a while. This project has been kind of long. Oh, let me stop recording just so I have everything recorded. I'm going to let this finish. I can screen capture this and speed it up. I'm doing one iteration per frame, yeah. So certainly that would be another way, but even so, it's the computation that's really slow. I wonder if, like, am I doing stuff? Am I wasting a lot? No, if it's not collapsed, so just go right on. So I think there's probably some optimism. I just want to know if there's any like simple optimization I could do. Would it be possible to implement edges, and I mean board edge tiles, so they can only go to the edge of the canvas? Interesting. I don't think it's the computation. I think we have a bug somewhere. Maybe. I'd love to discover that. I mean, look at this image. I just wanted to like tweet this out right now because it's just so beautiful, but I'll do that later. I'll do that on my own time. Look at that. Oh, I love it so much. An image has never made me so happy. I mean, I didn't design this at all. It's just from the example. And then, of course, thank you to American 2050. Could it start in multiple places? Would they all join up at the end? They would if we got lucky. So like we could definitely, and that would be an interesting thing to try. I also could probably collapse more than one tile per frame. There's lots of ways. There's lots of things that we could do. I think JavaScript is just slow. Like all these arrays and all this like checking and string equality. I mean, I'm just doing a lot of extra. There's a lot of redundancy in the code, I think. So it certainly could be optimized. All right. So I think my plan is to stop in a few minutes, but you should all stick with me here because we're going to all head over to Sable Ralph's stream. The string reversing might be slow. I mean, it was running slow yesterday, even though I was just checking numeric equality. I don't, could be. Symmetry for tiles 10 and 12 wrong. Oh, yeah. No, there's lots of tiles I don't need to rotate 4 times. So that is also an optimization. There's lots of tiles here that are redundant that I don't need to, like this tile only needs to be rotated once. There's only 2 versions of this tile, but I made 4. And same with this. This one, though, does need to be, yeah, so this only needs the same. I'm trying to think about this one. Yeah, same with this tile. So most of these tiles, so that I could really optimize for. Like what tiles need to be rotated 4 times. This one, this one, this one, this one, and this one. So none of these, so I could, that's something that I could probably, I wonder how much faster that would make it. Somebody should try that. You made it 4, it should be 3. Oh my God. No. It's correct. Oh, no, this is correct. Because I'm rotating it 1, 2, 3. Because it's J starts at 1 less than 4. So it is correct. But I do like the idea of just rotating them all because it will, like Kayfan just said, it will generalize to everything. I'm trying to think if there's some other things I wanted to go over and mention. All right, actually, so hello everybody. Please come and join the Coding Train Discord. I just want to give you some tips here. So I'm putting, the Discord should be, while you're here, I would like to just, for those of you that are watching, obviously you're watching the live stream, you might want to know when are the live streams. So under here, in the Discord, I am always tagging @notifications. So I very rarely, once a month, I allow myself to use the @everyone tag for certain things. So that'll usually be under announcements. You'll see that I often try to, so the last one I did was April 1st. So I use an @everyone, I'll do it May 1st, maybe. Once a month to kind of like update people, but I don't like to just ping everyone all the time with every quick update. But if you want to get those pings for because often I'm like, oh, I think I'm going to live stream tomorrow. And then I change the time to an hour later. I will do that continuously. What you should do is join the Discord, go to, I forgot to make this an event today, go to the README. So I believe the README, you need to emoji react to the code of conduct, I think down here. So when you first join the Discord, you won't see anything. Then if you emoji react here to any of these, it will unlock all of the channels for you. Please read the code of conduct before you emoji react. That's the idea of having that step in there. And then you can go into, there's a supporters channel. If you're a Twitch subscriber, YouTube member, GitHub sponsor, Patreon, there's some private supporter channels that will unlock for you. And then, but if you go to the cafe and under bot talk, you can put in the command. Here is the Discord link. I'll put it again in the chat. You can just do !Discord and it will come up. And I believe it is subscribe, !subscribe, which removed. So that just removed the notifications role for me. So if you use this command, !subscribe, that will subscribe you to any of these notifications. And I'm trying to be more active in the Discord. If you have suggestions, how to make things better. If you have questions about the Discord, tag Station Manager. Station Manager is the role for the Discord moderators. You can also tag Saint Plays, who is the manager of the Discord. You can tag Katie, who does community management for social media and all sorts of other things for Coding Train. So yeah, so that's that. And thank you, Alka, for posting the repo. It is noon, so let's have a look and see. I'm going to check my Twitch dashboard here. And I'm going to see if Sable Raff, he started. So we're going to now raid Sable Raff's live stream with a wonderful interview and live coding session that's going to happen. I'm going to stick around and watch some of that. If you have time, take a break. And, if you've been watching this stream, you might want to take a break for yourself. But give it a watch if you can. I'm going to go to my Stream Manager Video Creator dashboard. Stream Manager. And I'm going to click Raid. And I'm going to click Sable Raff. And, it just said starting soon, but let's head over there now. Here we go. All right. Everybody, get ready to be the kindest, friendliest, most generous raiders on the internet. The Coding Train is just leaving the station, leaving the Coding Train, the Schiffman station, and pulling into the Sable Raff station for Creative Coding Weekly. And I'm going to hit raid now. Here we go. All right. I think we're there now. You shouldn't be hearing me anymore. I have to stop. I can stop my stream, right? I'm going to stop my stream. I think that's what I do. I'm muted? No.